Hey, in this video I want to show you a way to create an IK spline, a general purpose one. There are many ways to create an IK spline. I'm going to use cMuscleSpline because it's a method that it's not really often talked about, but I find it very useful. I think there are very limited resources to this online, so I hope that I can show you something new. Typically, IK splines are created with NURBS curves and then some clusters, and well, they all have their pros and cons. I find cMuscleSpline to be really good, and yeah, that's why I've chosen it as my favorite method. It's not perfect, but it will serve us hopefully well. So the first thing that we need to make sure is that the muscle plugin is loaded. So we go to the plugin manager, we type in muscle, and make sure Maya muscle is loaded. That's great. And then under skeleton, no skin, no deform, there you have the muscle submenu, and there you have bonus rigging, and then you have create muscle spline. This opens a little UI, and there you can specify how many controls you want. I think we're going to just leave the default options. That means we have 3 controls, one in the beginning, one at the end, and one in the middle, and 5 joints. And then we're going to create a constraint for the mid control. Yeah, I'm just going to hit create and take a look what we got. So here's our top. Here's our bottom, and as you can see, the mid one is constrained between these two. And then we have this spline here, that's that yellow line, and the mid control is constrained between these two. And if we take a look at how they did it, we can see that's actually a very simple way they did here to constrain the middle control. By using a point constraint and then an orient constraint to interpolate between this and that rotation. And I think that's not really the best way to do it, because it leads to a spline that's not really curved. You see this little bump here in the curve, and what we're going to do is make it a little bit nicer than that, but using the same methodology. So if we take a look here, so that's actually the node that we have, and this one, that's the cMuscleSpline node. It has some input data, read data, and some output data, and it also has these jiggle features, and yeah, but we're not really going to use that. Right, we just want a very simple IK spline, but we're gonna keep this thing around here and use it as a reference. I'm just gonna zero out the transformations here, so we are at our rest pose. Okay, yeah, so the main thing is the read data, I believe. I'm just gonna select the top control, and if there are too many nodes here present in the node editor, I'm just gonna hit here twice to make sure there's one. That means the depth of the dependency graph displayed is only 1 level deep, so we only get the nodes connected directly. So let's see what's connecting into the cMuscleSpline. So that's control data. And the main thing is you see all these jiggle attributes that make it complex, but the actual transformation that's here, that's the world matrix, goes into control data. Okay, so let's create a custom cMuscleSpline. I'm going to hit tab, write cMuscleSpline. So this is now our custom muscle spline, and I'm gonna hit create a locator, and I'm gonna create another locator, and these will then go into the cMuscleSpline. We don't need the shape nodes, so we're gonna get rid of those, and locator 1, so now let's try world matrix, goes into control data, and do we see this here? There it is, control data, but it doesn't have any items. Okay, so we could try doing that with the connection editor, but I believe the result will be the same because the array length is just too short, doesn't have any elements. Yeah, okay. So that's when we need to write a little mel script, and what we're going to do is connect attra. Oh, let's write Python because it's more useful. If you actually learn some scripting, then you probably should learn Python. So this is now a way to import the Maya commands, and the Maya command that we are going to use now is connect attra. That's for connecting attributes, as the name suggests. And we're going to take locator 1 world matrix, and we want to connect it to cMuscleSpline. Control data, and the array element is 0. You always have errors when there are multiple elements. You see that's an array element, so control data, and then square bracket 0, square bracket 1, 2, and so forth. And then the actual attribute name is insert matrix. Control data dot insert matrix. Okay, let's see if that works. Cool, so we have now here this connection, so that actually works. And now we can do the second connection. We're just going to copy the line and select the line and then hit run. And now we can see this actually worked. Now we have this connection here. All right. Okay, so then we'll create another locator. That should be the third one in the middle. And we're going to take a look how the output data is connected. I'm going to select the cMuscleSpline node, go to output data, and let's see, output translate, and then that goes into the translate and rotate. Right, so you have an array attribute here as well again. You see output data 0, output data 1 with the brackets and so forth. And then these array attributes have child attributes, and these are then called out translate and out rotate. Small tip, if you don't really know what they are really called, because then it's important if you write like a script to have like the correct naming. What I sometimes then do is I disconnect it, and then here in the script editor, Maya tells me the exact attribute name, right? So, and then I undo this step to get my connection back, but I know the exact name of the attribute. So let's try plugging it in here. So where's my third locator? It's here, and output data, oh, here we have the attributes. So we don't need to connect the individual ones, but we can take the compound attribute. So translate is a compound attribute because it has child attributes, translate X, Y, and Z. So let's connect translate, let's connect rotate. And then we need to tell how far it is along the spline. So where do we specify that? That's the U value. You see with the U value here, you can specify where along the spline this joint will be located. And we need to check where that U value goes in. So the U value attribute goes into, what's this thing doing here? Read data, read U. So it's not control data, but read data. Read data, read U. So let's see if we can connect to that attribute. I mean, we could at first add an attribute here. We can call it U value as well. Doesn't really need to be keyable, so I'm going to make it displayable. It's going to be a float, and minimum 0, maximum 1, default 0.5 because it's supposed to be in the middle. And now let's see, where's our read data attribute? Can't see it. So let's see if we can connect it like this. There's read data, but again we have no elements in this array. Sometimes in the attribute editor you can add elements, but yeah, I can't see that here. So that's why we have to again resort to scripting. So let's take the third locator, U value, and then we go into read data 0. What's the attribute name? Read U. Just to make sure, we're going to disconnect and connect. So what's it called? A read U. So this actually worked. Okay, so theoretically we should have now a spline, and actually we do. See, the cool thing here is now that we have this spline that's being displayed. We can control that display. We can say it's off, or we can say spline and points, so the control points are displayed. We can display the tangents, and we can just say don't show it to me at all. And let's show this for a moment. And what I really like about the IK or the cMuscleSpline is that the tangents work really well, in my opinion. You see, even as we change the length of the IK spline, we still get nice predictable tangents. And yeah, I think that's a very nice feature of that. And you see the interpolation here is really nice. It's much nicer than what they have here. You see here you have those bumps, and here you get this nice curve. Okay, so the idea now is that we use these three guys now for our actual IK spline, right? So here we have those three controls. Feeding into the IK spline. And the nice thing then about having 3 controls is that you can manipulate the middle, and that's something you sometimes want. You know, if you have like a spline, like a spine or a neck, then you want to be able to control the middle, and this is what you get when you actually use 3 controls here. So technically we could now actually connect our new locators to the existing one, the one that we created here. But I think it's cleaner if we write it from scratch. For the moment, I'm going to hide this thing here, and start naming things a little bit nicer. So this is the spline shape. This is actually the cMuscleSpline. If we give it a name like this, yeah, the shape gets renamed automatically. Then we call this, I don't know, spline signal control. This is the 2 control. And this is the 3 control. And yeah, as you can see, the spline is always aligned with the y-axis. That's something I believe we cannot control with the with the cMuscleSpline. I might be wrong about that, but I haven't found a way. Maybe there is, but I think there is not. So usually they are then aligned the y-axis. This is not a big deal. We can just simply, you know, orient our controls if we want to have a different alignment, or make the have the joints that are then connected to the IK spline have offset controls, so that we can orient them in the way we want. Okay, now we have these and this. All right. Yeah, I think we're going to make a cut here, and then we're going to continue in part 2.